Hey guys, welcome back. This is Physics for Life Science. So today we're going to pick it up with Coulomb's law and vector in 2 dimensions. So if you haven't watched our video of vectors and Coulomb's law for 1 dimension, I would suggest you to go back to it and check it out because otherwise this video will make no sense to you. Alright, let's begin. So we're going to start, unlike last video where you only had two charges aligned with each other, now we're going to start with this example where you have three charges away from each other and you're going to find what the overall charge on one of them is. So let me correct something really quickly and let me just make this circle a little bit more aligned just because I want to make the two bottom charges parallel to each other. Alright, there we go. That makes it a little bit easier. Alright, so now let's assign values. So let's call this, or this is going to be a positive, this is going to be a positive, and this is going to be a negative. Now Q1, I'm going to call this Q1, Q2, and Q3. Alright, so now the value of each of them is going to be 50 microcoulombs. Of course, the negative, so the charge will be negative. For Q2 is going to be 35 microcoulombs. And for Q1 is going to be 60 microcoulombs. Alright, so now the differences, the distance between them is going to be what matters. Now remember also that there's the principle of superposition, which if you don't know what it means, just go back to our previous video and we'll explain it more in details. So now let's assume here you have a 90-degree angle, right? So then this will be a 30 and 60. So I'm just giving you this angle. So if I just tell you here's a 90-degree angle and here's a 30-degree angle, you will be able to calculate the distances. So I'm just going to give them to you here just so we can work this problem out. So this is going to be 30 centimeters. This right here is going to be 52 centimeters apart. And the hypotenuse is going to be 60 centimeters apart. Alright, so now let's say the problem is going to ask you for the force, the overall force in Q1, alright, and direction, of course. So overall force acting on it. So now you may be wondering, oh my god, how do I do this? You have two charges and then they're apart. What do I do? So remember, first thing to do is just calm down, and then second thing is look at the problem. If you were to ignore the negative, what happens? It just becomes a one-dimension problem, correct? Where you have two positives right next to each other. And remember what happens when they are the same charge and close to each other, they push each other away. So let's find out the force for that first. So let's just say force 1, force exerted by charge 2 onto 1 is going to be equals to, as we mentioned on the previous video, remember the formula is K Q1 Q2 over R squared. So in this video I'm just going to be plugging it in directly. So Q is 9 e to the 9. I'm going to be skipping units, so if you have any questions about units, please refer to our previous video. So what's charge 1? So charge 1 is just 60 e to the negative 6 coulombs, right? And then what's their charge 2? 35 e negative 6 coulombs as well. Divided by, oh that's a terrible line, I apologize. Divided by, now what's the distance between them? 30 centimeters. So remember, we're always going to have to convert to meters. So it's 0.3. And now I suggest you pause the video, plug this in please, and make sure you're getting the same answers we do. So I get 210 newtons as a force pushing it away, of course, as we said previously. Alright, now for our charge 3 onto 2, now our force 3 to 1. Now, remember that the concept of superposition tells us that they're going to act on each other like there was nothing else around it. So you can forget about this positive charge right here and neglect it right now. So for the force exerted by charge 3 onto 1 and 1 onto 3, because of Newton's third law, it's going to be the same thing. K constant, charge 1, of course, 60e to the negative 6, right? And then charge 2 is 50e to the negative 6. Now remember that I'm leaving out the negative just because if you remember from our previous video, the signs sometimes are confusing when it comes to directions, so we're just going to have to figure it out by hand. So after plugging this in, I get 75 newtons as a force pulling it towards each other, correct? Because a positive and a negative opposites attract, so they're going to be pulling towards each other. So now let's draw a diagram. Diagrams are very helpful, so I would suggest you for physics always do a diagram. So now let's isolate Q1. So if we isolate Q1, it will look something like this. Q1, where it's a positive Q1 and the forces acting on it, just because we calculated them already, would be force 2, 1, which would be pulling it down, correct? As we say, it would be pushing it away. I was confusing F2 with F3, I apologize. F2 would be pushing it away, so because Q2 was below Q1, that means it's going to be pushing it up, right? So now our force right here, this force is the force 2, 1, right? A force exerted by charge 2, which is going to be pushing it away from each other. And then by the same logic, now we have F3, which is going to be pulling it in at a certain angle, right? With a lesser force. So let me draw the arrow smaller so it may make a little bit more sense. Or if you're a visual learner, it might help you out. All right, so now from very, very early in physics, we learn how to combine vectors. So we have two forces, so all this boils down is combining them and finding the overall force, which would be somewhere, I don't know, in the middle, somewhere here, I'm just going to say, right? So I'm just going to say it's going to be somewhere here, our overall force, right? So now our duty is to find that overall force. So how are we going to do that? Well, remember from physics 1, we can do a x and y coordinate. So let's go ahead and do that for this charge specifically, right? So we already have force 1. We do a y-axis and we do an x-axis. Now we can just break the components, correct? So let me erase this just so it doesn't confuse anyone. There we go. Imagine it's not there anymore. There, now it's gone. All right, so now let's break this down into an x and y components like we have done previously. All right, so let's go ahead and do overall or total sum of the forces. I'm gonna make this a different color just so it makes more sense because it's the overall forces sum of the y is going to be equal to what, guys? So what do we have for the, I think this is too much of a shiny color, so let's switch it there. So sum of the forces over the y. All right, so for the F to 1, all of that forces into the y. So we have 210 newtons positive, right? Because going up is always positive. All right, so, and then, but what about for the F31? for the F31, we know that's at an angle, right? And we remember from physics 1 that in order to get something from an angle is going to be the hypotenuse, so 75 newtons, and now negative because it's going down, it's pulling away on the opposite direction from F2, so negative 75 newtons times, how do we know? What angle? What were the angle? What are the angles? So this is when these angles come really helpful. So remember here 60 degrees? Well, those 60 degrees is the angle at which this force is pulling. So it's 60 degrees. So how can we find the y component? It's not the opposite, so it's the adjacent of the angle. So therefore, we're going to use cosine. Now, if you don't know why I'm using cosine, I would suggest you to go back in our vector videos, and I make a very clear explanation of why it's cosine. Okay, so now I'm just going to keep going forward now. So now let's do some of the forces. So if we put this together, please do, compute it on your own, you end up finding the overall sum over the y is 172.5 newtons positive. All right, so now let's do it over the x. Same thing. All right, sum of the forces over the x is going to be equals to a certain number. What are the forces acting of F21 on the x? None, right? So this is going to be 0 newtons. So maybe let me just put here x. This might clarify it for some people. Y, x. And then now I'm going to go with F31 over the x. What is that? So because the x is the opposite from the angle, it is actually going to be 75 positive. Notice the positive. This is why I was saying be careful with the signs, because here we're using a positive, here we're using a negative, just because that's how our coordinate ends up working out. So be very careful there, because a sign may give you a wrong answer. So 75 newtons times the sine 60, and that is going to give us 64.95 newtons. All right, so now we have our total x and our total y, right? So we know that it's going to be, because both of them are positive, that means our overall vector is going to be in the first quadrant. It's going to be somewhere here, right? Somewhat there. Oops. So now we need to calculate the magnitude. So remember, magnitude is calculated using the Pythagorean theorem. A squared plus b squared equals c squared, right? So now that we have our coordinates, or that we know that our y is 172.5 newtons and that our x is 64.95 newtons, we need to find the hypotenuse, which we're just going to do c is equals to square root of a squared plus b squared, which in this case is just either of these squared, take the square root, and I am going to get 184.3 newtons for my hypotenuse. So that's the force, that is the magnitude of my force. Now I need to find the direction of my force. All right, so now I'm pretty sure you guys are starting to see where this is going. So in order to find the angle, it's always tangent, right? Inverse tangent of opposite, which in this case happens to be our y, over adjacent, which is our x. And if you plug those numbers in, you should get 69 degrees. So our overall force is 184.3 newtons at 69 degrees. So I hope that was useful, guys. I know, to me, honestly, for me, this was one of the hardest topics working with vectors in 2 dimensions using Coulomb's law. But I hope this video made it a little bit more simple and that it's helpful for you guys. So please, 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 if you like this video, like us on YouTube, on Facebook, comment, subscribe, and let us know how we can help you. Just we're here for you guys. So let us know how we can help you, and good luck with your study, guys.